Alright, so here we go. Here's another example on graphing a rational expression. So this is from section 4.3. I do apologize, my voice is a little scratchy this morning, so we'll see how it goes. Alright, so question 1, or part A on the exam, will be the first step, and that is to state the domain. Now remember, when we talk about a domain, that is whenever you will exclude whenever you take a square root of a negative number, or when the denominator is 0. So to get the domain of this function, the numerator does not matter. The domain of this function is whenever the denominator is equal to 0. And that's what we're going to exclude. So when x is equal to 5, we get 5 minus 5. So that means we want to exclude from the domain the number 5. So that's going to be all real numbers from negative infinity to 5. Now remember, we're not including 5, so we want to use a parenthesis as opposed to a bracket. We're then going to go ahead and union that from the interval 5 to infinity. By writing it this way, we exclude exclude that 5. Now, in this first step, it's also beneficial if right off the bat you go ahead and factor the numerator. In this particular example, the denominator is already factored for us, so we do not have to factor that. But if it could be, you should. Okay. Now the second question asks, is the function in lowest terms? In other words, is there a common factor in our expression? The answer here is clearly no. We can't cross anything out. So the function is, my apologies. The function is indeed in lowest terms. All right, we cannot cross anything out. So this function is indeed in lowest terms. So no, we can't cross anything out. Therefore, it is in lowest terms. Part C on the exam asks to find the intercepts, if any. Okay? Now, the intercepts, we're talking about two cases. The y-intercept as well as the x-intercepts. Those are two things I will be looking for on the exam. To find the y-intercept, you're going to go ahead, you're going to set x equal to 0. So in other words, you're evaluating this function, the original expression way back here, at x is equal to 0. So this gives me 0 squared minus 0 minus 12 over 0 minus 5. So this becomes then 12 over 5. Now as far as the x-intercepts go, we want to go ahead, we're going to set y equal to 0. Now remember, y is just another name for r of x. Okay? So we're taking 0 equals, I'm going to use the original one, so x squared minus x minus 12 over x minus 5. Okay. Well, in looking at this, if I were to multiply both sides, oops, you can't see, by x minus 5. Okay. Over on the right-hand side, the x minus 5s will very nicely cancel out, and that'll just leave me x squared minus x minus 12. On the left-hand side, I have x minus 5 times 0. Well, anything times 0 is just 0. Okay? Now, this is a regular quadratic equation, so we could go ahead and factor it. Okay? This will be x minus 4 and x plus 3. Now remember, in order for a product to be 0, one of these factors has to be 0. So I have two x-intercepts here, x equals 4 and x equals negative 3. Now we said before that in order for there to be x-intercepts, they have to be part of the domain. 4 and negative 3 are indeed both part of the domain. Alright, so the next question, this would be part D. Is there a vertical asymptote? Now, vertical asymptotes come from the denominator of our rational expression. Okay? In other words, wherever they equal 0. If there was a common factor between this, that would simply be a whole and not a vertical asymptote. Since the x minus 5 does not cancel out, that means I do indeed have a vertical asymptote where x is equal to 5. And yes, you must say x is equal to 5. Now when we look at a vertical asymptote, we have to take into account its behavior, okay, around 5. So as x approaches 5 from the left side. Now you can pick x values to go in here, okay? You want them to be fairly close to 5, but not quite there just yet. I'm going to go ahead and pick 4.5, 4.8, and 4.9. In class I was doing like 4.9, 4.99, 4.999, okay? Any of those would work. You also want to take a look, see how the graph's behaving as x approaches 5 from the right. So in other words, slightly bigger than 5. So I'm going to go ahead, I'm going to pick numbers like 5.2, 5.1, and 5.01. Okay? Now, you're going to take this number and plug it into the original expression wherever you see an x. If I may make a suggestion, okay? When you go to evaluate r of 4.5, okay? Enter the numerator into your calculator by itself first. So take 4.5, oh, this is really hard to do on the phone. Where's square? Oops, helps the calculator's on. Okay, minus 4.5 minus 12. Okay, so type that into your calculator and get a value. Do the same thing then for the denominator. This will be just 4.5 minus 5, which is a negative 0.5. Then go ahead, do that division. Okay, and that gives me my first value of a negative 7.5. Okay, so you're going to go ahead, repeat this for each one of those numbers. Okay, now since these videos aren't excessively long, I'm going to go ahead, take a break here, fill in the rest of this chart.